Okay, great. So thanks again, all of you, for being here again in this first open workshop of DOMMINIO project. So I'm going to present briefly the project and to talk about the concept and the main pillars that we are developing with a little bit more detail, and then we will give the floor to some work package leaders to present their approaches. Mostly related to manufacturing, digital side, and also the digital twin concept for them. Okay. So yeah, we were listening to three interesting presentations about thermoplastics, additive manufacturing, and digitalization at high level. Very relevant actually to our concept. We are firmly betting for thermoplastics actually, and for out of mold manufacturing or out of autoclave as well as AFP and FFF, and also trying to, from the bottom up approach, let's say, to create this digital thread, this data all across the life cycle, as I mentioned before, to make or to accelerate the development of next generation multifunctional composites manufactured by highly innovative manufacturing technologies. So just a brief overview about the project. DOMMINIO acronym comes from Digital Method for Improved Manufacturing of Next Generation Multifunctional iframe Parts. It's a project submitted for the MG35 topic last 2019. It's a research and innovation action. We aim at reaching TRL4 for most of the technologies during the 42 months of the duration of the project. We have 30 partners and almost 5 million of budget. As I mentioned before, the project life is one year, almost 1 year already. So there are some developments that are that didn't start already, but we have some of them that we can discuss later. Okay, so I don't know what's going on. Okay. This is the background I explained before. So yeah, the idea is we need more competitive and sustainable products. We need to increase efficiency, cost effectiveness, and flexibility for the high production rates and the ever-increasing complexity of products. So this is the framework for the call text on the needs for European industry. Actually, this call text was written before the COVID situation, so you can imagine that this is almost more urgent, let's say. So the idea is that in order to advance in design, production, and field operation of multifunctional intelligent iframe parts, we are developing this DOMMINIO knowledge-based integrated design, manufacturing, and optimization based on the digital threads. And we want to ensure from the early stage of the consolidation of next generation composites, the quality of the products, their manufacturability actually, and their potential flaws in the certification aspect, let's say. So the main pillars are those ones here. We are developing an FFF and AFP new manufacturing scheme. We want to manufacture composites making use of both technologies. For example, plies with AFP and stiffeners with FFF. Just an example. In terms of materials, we are developing 3 different filaments for based on thermoplastics that will be manufactured by FFF. So continuous carbon fiber for reinforcement, continuous carbon nanotube fibers for sensors, and magnetic nanoparticles for induction welding and disassembly. Adaptive manufacturing with closed loop control strategies based on infrared control of laser heating, and inline quality control of potential delamination during manufacturing, for example. And everything generating somehow data where a database optimization will be executed based on the data acquired all across the life cycle. So if we go, well, this is a little bit the concept relies actually on what is called the multidisciplinary design optimization. This is a current practice, especially in the aircraft industry, that needs every time that a new concept is proposed, a design loop or an iterative design loop between different disciplines has to be carried out. Conventionally, of course, aerodynamics is one of the most important disciplines that plays a role here, but also a structural element, structural performance, cost. So the idea is that multidisciplinary design optimization is the framework where all these disciplines interplay to come together to an optimal solution, right? So DOMMINIO wants to bring to the multidisciplinary design optimization loop an additional discipline, which is manufacturability. So every time that a new concept is proposed, the manufacturability should somehow be aligned with the concept of the new design. So the idea is that how to bring this manufacturability into the multidisciplinary design optimization loop. So we rely on data, right? So here you can see is the new designs of multifunctional and intelligent airframe parts will exchange data with the simulation. This is the steps all across the life cycle. So we simulate product and also simulate the manufacturing, for example, simulation of FFF and AFP. So after this, we come up with an engineering scheme. We manufacture actually the product, and we obtain data during manufacturing with the position of the robot, the identification of the heating input, potential defects that are identified with the inline quality control. So we have in this stage data all across the manufacturing. And then since we are developing sensors, embedded sensors for structural health monitoring, the idea is that we also have this information that are exchanged in the MDO somehow. In terms of structural health monitoring, we have an additional functionality, which is to provide MRO with condition-based maintenance schemes instead of predictive maintenance. And this somehow enhanced with the ability of thermoplastic to be repaired or disassembled with the magnetic nanoparticles that we are also developing. Okay, so this is more or less the concept. So we try to include manufacturability and all the data all across the life cycle into the MDO to provide database knowledge. So this is the overall image or the concept. So we have the product. Sorry, because I cannot see here. So the blue stage would be simulation and product planning. The red one would be, and the orange, the manufacturing, and then the in-service operation, right? So this is once again the concept with a little bit more colors and details. And one of the most important things is that we will gather all the data from the process, from the quality, from the sensors, and take it back to the MDO for design for manufacturability discipline. So this is once again the concept with a little bit more detail. So the idea is in DOMMINIO we are working with, we are combining, this is a better word, ATL and FFF to really exploit the synergies between both technologies, in situ consolidation for AFP, and also dedicated sensorized nozzles for FFF, and also developing the innovative materials. On the other hand, the quality by design strategy, I mentioned before, the laser scanning, the nozzle with thermal control, and the inline quality control. digital aspect of Domminio has two, let's say, pillars. The data-driven pipeline supporting the design, simulation, and production planning. So here, the numerical simulation AFP or ATL will describe the city consolidation of FFF quality. We will have a presentation today later on. And the idea is to really identify cross-correlationship between simulation, production, defects generation, right? And yeah, since we are developing new materials, new sensors, the structural health monitoring is also a very important part of Domminio. So on the one hand, we need to develop a methodology to really know how to locate those sensors in the laminate. So this is not a straightforward activity. Actually, we need to know really what is the function or the gauge factor of those sensors and their ability to really identify critical aspects of performance of the products. So we are also developing this digital twin based on multi-scale modeling to really see how is the performance on the sensors before we manufacture them. And after this, when we have the service stage, as I mentioned before, those sensors will provide key information about the structural health of the composite. And finally, as the Domminio acronym says, the digital methodology that we are providing is to bring all the knowledge that we generate during the simulation, manufacturing, and in service into an MDO, so we can support the generation of new designs based on data. Talking about KPIs that we promised during the proposal preparation. In terms of manufacturing, so we aim at reducing 25% of manufacturing costs by coming up with near-net shape automatic process. In situ consolidation, this is one of the great advantages as an out-of-autoclave manufacturing approach. To reduce 25% the product and process design time, since we are targeting to include manufacturability as a new discipline, we think that with the interplay between several disciplines, this will help to really come up with optimal solutions in a faster way. In terms of scrap, we will reduce 15% of the scrap we produce in manufacturing based on the multi-stage approach of FFF and AFP, which produces less scrap by itself, and also because we are developing these serial-fed manufacturing approaches based on online control. And finally, also because of the use of lightweight materials and optimized designs, we will reduce 25% of component weight. We'll reduce 30% of costs in MRO operations, enabled by, on the one hand, the condition-based maintenance. We think that we can really optimize the maintenance, repair, and overhaul operations because of having actual data on the structural health, but also on the ability of thermoplastics to be repaired and to be disassembled with these new materials that we are developing. And in the long term, of course, we're talking about TRL4, but we think that with the multi-scale simulation approaches and with the online manufacturing control, we can also help to increase the potential roadmaps for virtual certification based on multi-scale or virtual testing. So final words about the consortium. I mentioned before, we are 13 partners. We have materials experts, manufacturing experts. We have simulation experts as well, and also end user representatives, which are bringing us a very good framework for all these studies. So that's my presentation for today. Very briefly to explain our project, which has 1 year life already.